For PMF of a random binomial random variable is n choose x p raised to x into 1 minus p all raised to n minus x. So this is the PMF of binomial random. So let us define mean of a binomial distribution. So what we will do is let x follows binomial. Okay, we will denote by n p. P is probability of success and n is number of trials. So we know that definition of mean x mean mu is equal to expectation of x. So tell me what is expectation of x. Okay, so if we have x follows binomial np, we have p of x is ncx, or we can n choose x p raised to x into 1 minus p all raised to n minus x, where n ranges from 0, 1, 2, etc. So here n equal to 0, sorry, x ranges from 0, 1, 2, etc. to n equal to 0 to n x into p of x, n choose x p raised to x into 1 minus p all raised to n minus x. Now we know that ncx is equal to n factorial divided by x factorial into n minus x factorial. So this is the definition, that is n choose x. So we know that x factorial, if x is an integer, this is 1 into 2 into etc. x minus 1 into x. So now we can write this as sigma n equal to 0 to n, x equal to 0 to n, x into n factorial divided by x factorial into n minus x factorial p raised to x into 1 minus p or raised to n minus x. Now, so what we will do is, here x ranges from 0 to n, here x is there and x factorial. So you can cancel out, you get x minus 1 factorial, sigma x equal to 0. So x minus 1 is there. So we will start it from x equal to 1 to n factorial divided by x minus 1 factorial into n minus x factorial p raised to x into 1 minus p all raised to n minus x. Now I want to find, so here there is x minus 1 factorial is there, here n minus x. Okay, so what this n factorial is actually n into n minus 1 factorial, n into n minus 1 factorial. So this is equal to, if you take n outside, I'm taking n outside, n into x equal to 1 to n minus 1 factorial divided by x minus 1 factorial. Now I can write n minus x as n minus 1 minus x minus 1 factorial. So n minus 1 minus of x minus 1 is same as n minus x factorial. Now I am taking p outside. So n into p, x raised to p raised to x minus 1 into 1 minus p into, I can write n minus x as n minus 1 minus n minus x minus 1. n minus 1 minus x minus 1. So x ranges from 1 to etc. Okay. Now, if you have any doubt, you can ask me. So now we can write np sigma x equal to 1 to n. This I can written as n minus n minus 1 choose x minus 1 p raised to x minus 1 into 1 minus p raised to n minus 1 minus of x minus 1. So this is actually a binomial series. So this I can written as np into, this is actually instead of a here p, so p plus 1 minus p all raised to x minus 1. So p plus 1 minus p is 1. So the answer is np. So therefore expectation of x is equal to np. So expectation of a binomial random variable is np. So now we want to find out variance. So how to find out variance? So by definition, variance of x is expectation of x square minus expectation of x all square. Expectation of x square, both are same. Expectation of x square or expectation of x all square. So we already know that expectation of x is n into p. Now I want to find expectation of x square. For that, I will take expectation of x square as expectation of x into x minus 1 expectation. So expectation of x square is expectation of x square x into x minus 1, sorry, plus expectation of x. So we know that x into x minus 1 plus x is x square. That is the, so now we will find, first I will find this one. This I already know, that is n into p. And expectation of x into x minus 1, by definition, this is x equal to 0 to n, x into x minus 1 into n choose x, p raised to x into 1 minus p raised to n minus x. So this is sigma x equal to 0 to n, x into x minus 1. This can be written as n factorial divided by x factorial into n minus x factorial, p raised to x into 1 minus p all raised to n minus. So x factorial is actually x into x minus 1 into x minus 2 factorial. So I can cancel sigma x equal to 0 to n factorial divided by x minus 2 factor. Okay, so here x minus 2 is there. So I'm setting x equal to 2 to n minus 2 factor. And now n minus x I can written as n minus 2 into x minus 2 minus x minus 2 factorial, p raised to x into 1 minus p all raised to n minus x. Similarly, now here x minus 2 factorial is there. Okay, so now I'm taking n into n minus 1 outside, x equal to 2 to n, n into n minus 1 outside, then n minus 2 factorial, x minus 2 factorial, n minus 2 in minus x minus 2 factorial. Now I'm taking p square outside. So here p raised to x minus 2, 1 minus p into n minus 2 minus x minus 2. So now I can write this as n into n minus 1 p square. Okay, so this is actually in a binomial form, binomial series. So instead of a here, p, and instead of p here, 1 minus p. So you can write p plus 1 minus p all raised to n minus 2. So the maximum power is n minus 2 is equal to n into n minus 1 p square. So therefore e raised to x square is equal to n into n minus 1 p square, and there is plus e of x is there plus. Now what we will do is we will find variance. So variance is n into n minus 1 p square plus np minus, so we know that e of x square minus e of x all square, that is variance, right? So e of x all square is np all square. So now you can write it as n into n p square. So n square p square minus, that is np square minus np square plus np minus n square p square. This can be written as n square p square. So this n square p square minus n square p square get cancelled. And if I taking np outside, then I will get 1 minus p. So therefore np 1 minus p is the variance. Or otherwise we call 1 minus p equal to q also. So sometimes we call probability of failure or 1 minus p as q. So either we can write npq. Okay, so this is the variance. So for a binomial distribution, so we find for a binomial distribution mean equal to np and variance equal to npq, or np into 1 minus p.